This is going to be epic. We're going to be talking about artificial intelligence, AI. Who's excited? There we go. That's good stuff. All right. Good energy. Innovation and the integration of AI, weird science, and technology in cannabis. You have an epic moderator for this, William Green, who's the CTO of Trees, and I will leave it to him to speak on this with his panelists. Thank you very much.
Thank you. Thanks, guys. All right, I'm going to introduce this panel briefly and then introduce myself. But I want you guys to see something interesting here. Energy, ad tech, and a couple other things. Alex will tell you about himself. And then we move over into biotech. Like, you guys just look at this panel. This is an assembly of people who, if I looked at this, I'd be like, how are they connected? What is this to cannabis, and how does it work? So we're going to find out. We're going to go into the details. And if you guys missed it, this guy did an epic 3-minute pitch last session. So just listen to him talk. I am William Green. I work at Trees. We are the #1 point of sale in California. So we're in 4 states right now, and we just got our first round of funding. And without further ado, yeah, thanks. All right, I'm going to pass the mic over and let these guys introduce themselves. We'll start with Chuck.
My name's Chuck Miller. I'm with WGL Energy. We're a energy services company based on the East Coast with renewable energy and on-site power generation across 22 states, and now entering and supporting the cannabis growth, cannabis space.
Thanks, Chuck. All right, Alex.
Hi, everybody. My name is Alex Maurice. I'm representing MediaGel, which is a advertising platform that allows you to connect with an audience that previously you haven't been able to connect to. My background is theoretical physics, and from that I was able to get into artificial intelligence. So I'm responsible for some of the AI that we have at MediaGel and at another brand that I can't mention yet.
Hi, I'm Melon Patel. I'm CEO of Pathogen DX. We're a biotech technology company. We have a lot of, let's just say, pathogen testing data from a lot of labs from a lot of states, and purely addressing some of the key issues that we're seeing in the industry. One of them, most of us are pretty familiar with, that 20 or 30% of the product that's out there is contaminated, and we're trying to address that key challenge.
And Ben Shirelli, I'm the founder and CEO of Celebre, and we are a biotech company that basically says that biology is the most sophisticated manufacturing technology on the planet, and we leverage biology to make products more sustainably, economically, and reliably across a variety of industries. To give you an example of this, actually, the cannabis plant is probably the most elegant example of biology as a manufacturing technology. If you take a step back and think about cannabis, one cell of that plant takes nutrients from the soil and water and makes 400 chemicals at the same time. That's crazy, right? But it's also a disaster from a product development perspective. So what we do is we engineer cells like yeast. We take the machinery and the DNA code from a cannabis plant. We feed those cells sugar water in a fermentation process and brew them like beer, making the same exact natural product, removing the need for agriculture completely from the supply chain.
Thanks, guys. Alex, we're going to come back to you and ask about that theoretical physicist thing. I need to learn about that.
Let's not. I tore an ACL even hearing that.
We're finding out, guys. All right, so you know what? Before we got here, I heard this really strange story about pigs. So I think we're going to start off with the pig story.
I think the pig story is your story, Ben.
The pig story is my story?
No, it was your story. But
He's denying it.
Yep.
It's your story.
It was a company that basically takes pigs' lungs, right?
Is that the one we want to talk about?
That's the one we're going to talk about.
Yeah, so I spent the last, just to let you guys know kind of where this technology came from, I spent the last 3 years working for a guy named Dr. Craig Venter. If you Google that, you'll find that he sequenced the first human genome back in the early 90s, announced that with Bill Clinton, and his mind was kind of everywhere. So I came up with this idea in the same space where we were doing, have you seen the algae commercials with ExxonMobil, the future of fuel? So that was my old company. And then another thing that we were doing was we were actually engineering pigs to be universal organ donors for humans. So you can actually change the DNA code in a pig to make its lung have proteins on it that makes it think that it's humanized. I wish I was one of these pigs, at least for a little bit, because they live in pretty much the 4 seasons for pigs. It's a beautiful facility, but crazy, crazy science, but all of it is really interesting. Biology has the opportunity to fundamentally change the planet in a lot of positive ways, and that's why if you were over at the pitch thing, I said I think biology is actually the most consequential technology that we have going today.
I do. I second that biology is the most consequential technology that we have going today. No, but I agree with that. What we have here is basically an organic material that is very, very important on multiple fronts, right? It's a food, right? It's an agricultural product. It's a therapeutic pharma. It's a pharma product. It's a diversity of different things, and so. And all of those dimensions of that product is effectively biology. So, sort of taking a step back, Ben and I sort of I think we've crossed multiple paths with my CSO and he's Craig Venter and a bunch of other guys for a long time. It's all around the genetics, right? So it's all around the genetics of this particular product, and how do you get clean genetics, in the product. And that's why he talked about the pig thing, because if you grow pigs in a sterile environment, you have no microbes or pathogens, and then you don't have to worry about it, but then you have clean pigs that you can sell to. So the nutshell of all of this is when you take a step back, what we have in front of us is sort of a tremendous opportunity. This industry is still at an infancy compared to the big B industries, such as in food, ag, water, pharma, and so forth. But we can leapfrog some of the dimensions of these technologies together by fusing them, by working together, and allowing, having that kind of collaboration, that partnership to advance the use of these technologies to make that product and make it clean. Obviously, that's my mission, but part of that is if growers use less fungicides and pesticides, you have a cleaner product. You'll wind up using less energy, basically. So, at the end of the day, what I have in front of me is essentially a platform that can address some of the clear challenges the food industry is having, which is 770 foodborne outbreak issues a year, right? Almost costing $54 billion a year in the world, right? I mean, in the United States. And that's sort of what we have in front of us, is partnering with people like Ben's company and others around here to address some of those challenges.
Thanks. Let's dive right into a follow-up on this. I'm curious what you guys see. So that the presentation is supposed to be on AI, right? So let's just start there. So why don't you guys comment on AI and data collection and what you're seeing in the industry?
That's you.
Oh, great. Okay. Hey, guys. Yeah.
Alex.
It's interesting. I want to be perfectly honest with everybody here. The company Media Gel, we've just started. It's about 6-7 months old. It's a place to have a platform to connect an audience that hasn't been able to be addressed before. You're not allowed to put a cannabis ad in the New Yorker, but lo and behold, you can put an ad in that doesn't have a big marijuana leaf on it, and you can actually do it now. So Media Gel allows you to have that space now where you can come in and say, hey, I'm a grower, or I want to get my message out there. How do I do that? So that, from the perspective of what the company does, is what we do. But from the perspective of artificial intelligence, that is a much deeper and more complicated situation. What AI essentially is a way to learn from data, from a tremendous amount of data, in a statistical manner. And instead of programming the computer, you teach the computer, much like you teach your children. You show it examples, and it begins to formulate hypotheses about what it's seeing. And now, if you do this for behavioral data, or data coming in through a website, or data coming in through a music site, or data coming in through people looking at cars on Ford Direct's site, or whatever it is, you can actually tell a tremendous amount about that, about these people. And this is where it gets really interesting from the perspective of AI, because what you'll notice that depending on how people interact or what they're asking for, it's what Google does, right? You can actually tell what their needs are. And you can actually infer what those needs are, and basically, once you know that, then you can service them. So that's essentially what we do with this other property that's called Yokana, is we are enabling people to have a conversation with a bot that that can tell them about the marijuana or the cannabis that they need. And it's a very interesting perspective from what you guys do, because there's a huge feature profile of a given strain. So there's terpenes involved, there's all these different things that give you this accumulated feeling that you get. And you as an individual might have a completely different experience than somebody else if they're consuming it. And you might just want wellness, or you might just want pain relief, or you might want a whole host of things that are, that heretofore have been inaccessible to a huge population in California and in the United States in general. Now that it's becoming legalized in many places, we're trying to connect to those people and say, hey, if you've never been in a dispensary before, or you don't feel comfortable talking to the guy with the white dreadlocks, right? Like, here's somebody for you that you can talk to and get you the right product, be it an edible or whatever it is. And so this is really interesting, because as data is flowing into the system, I'm seeing these preferences come out, and I'm seeing how many people want wellness, how many people are having backaches, how many people, X, Y, and Z. And so from that perspective, AI is an incredible resource, because there's no other mechanism by which you could take all this exogenous data, collect it, and then begin understanding what's happening.
And actually, there's a connection there to biology. Has anybody heard of a science called pharmacogenetics? Anybody? Raise hands. No? Cool, we'll do quick education. Pharmacogenetics is actually a spit test that you can take today that's used for opioids, and it's used for behavioral health meds. And it will actually tell you how you, based on your genetics, metabolize certain therapeutics, and therefore defines your dose for you. So what's really interesting to me, if there are any people that know scientists, somebody should be starting this company. I unfortunately have my hands tied with what I'm doing, but you can actually run these same tests and tell you how you will metabolize a THC tincture or a CBD tincture or a CBN tincture. And when we start thinking about prioritizing products and how do you really come up with a customized recommendation from a bot, you're taking all those qualitative factors that you're going to get from your information, and you could actually tie that to biology and say, how am I actually going to react to this, and what feeling do I want from a qualitative perspective? So I think there's a bunch of tech like that that is eventually going to come into this industry. It's been slow because, quite frankly, it's hard to get capital into this industry right now. But I think these are things that, if you're a product company, you should be thinking about, how do I personalize that experience for my customers? And these are the types of things I would keep in mind as you're doing that.
So you're probably thinking, what the hell does that have to do with the energy guy sitting up there?
We just brought you up because you're handsome.
Which is, I am the eye candy. I get that. But the Alex, this afternoon, you gave me a definition of what AI is. Do you remember what you said it was?
Essentially, what I said here earlier, which is that it's statistical learning that you don't have to hard code logic into. It learns all the logic through example.
And when they're applying this type of technology to people and to markets and to product marketing and even into biology, the same application, when you take it down to a microcosm in the energy space, is the learning. I'm not talking to people, I'm talking to plants. Your plants consume energy. Your plants take sunlight or artificial light, as it would be in this grow chamber, and they ask for things. They ask for water. They ask for sleep. They ask for food. All of those components are measured through the control systems that exist as part of the energy platforms that are ingrained in all of these indoor grow facilities. So from an artificial intelligence perspective, what we're doing is we're collecting that information and using it to optimize the growth cycles of the plants, the growth cycles of the products. When do they need water? When do they need food? When do they need the right temperature. Is my temperature warm enough? Am I warm enough? Am I cold enough? They're like little babies. You have to take care of them. So the idea of using this information in an art as a form of AI and as a learning mechanisms fits into the algorithms and the control systems that deliver and consume energy within these products. So I'm not here for just being the eye candy. I'm better than that.
But you are handsome.
Oh, you're blushing.
Okay, guys, so this is a good start off. Why don't you guys give some elaboration on like what technologies you guys are using to drive change in this industry, like what you're doing to like really bring about impact and change.
I want to go first because once Ben starts, we'll never get a chance.
Hashtag fact. It's trending.
So, from the energy perspective, you know, we're old school. I'm old school, right? I mean, you know, it's. Oh, I thought somebody was trying to speak over me. The aspect of energy and energy consumption for giggles, if there's producers in here, what are the two most expensive components of the product cycle? Anybody know? One is electricity, and the other is labor. The two most expensive pieces of your operation. So, and you know, energy seems like it's an old school type of thing, but there's lots of new technologies. A lot of companies are trying to become greener companies. They want to leverage renewable energies. They want to have green products. They want to have a green industry. So where does their energy come from? How do you optimize and how do you create a green environment or you know, leverage new technologies that are coming into the market, like battery storage, like fuel cells? So there's two aspects of it. One is the generation side and the other is the consumption side. On the generation side, we try to leverage solar, wind, biomass. We try to leverage cleaner technologies like fuel cells that use natural gas. If you're on the East Coast, almost 60% of the energy on the East Coast is generated from coal still at this point in time. So just switching over to natural gas reduces that carbon footprint by about 50%. So on the generation side, there's new technologies that can be applied, but on the consumption side, there's also ways that we can optimize the efficiency. One of the simple ones is what we call combined heat and power, where we're generating electricity on site behind the meter, and we're creating the power that the facility needs, reducing strains on the infrastructure, and then recovering the waste energy. The byproduct of generation of electricity is heat. And you can take that heat and you can use it to make chilled water through absorption technology and use that to cool the rooms and dehumidify the rooms and keep them at the temperature that those plants want. You can use it to generate warm air to add humidity to the room and maintain the temperatures that you need. But the end result of it is that byproduct is free. So as a result, your overall consumption of energy goes down by approximately 30% because you're getting a twofer. You're generating your own electricity and you're taking that heat and using it to create chilled water or hot water as needed. So there's lots of, even though it's not a new technology, it's a novel application into this space.
Yeah, let me share with you what we've done on the technology end with Pathogen DX. So most of you know what a Petri dish is, right? We've basically taken a Petri dish, and a Petri dish is like an abacus. You know what an abacus is? You know what a supercomputer is? That's what we've done. We've taken the abacus and we've wiped it out. We've wiped out the Petri dish, and we've created a product that can test for up to 40 pathogens in a single reaction, in a single sample, right? In triplicate data. So it's producing a crap load of data on basically the contaminant level of that sample. So in industries like the food industry and the water industry and the ag industry, it's a don't ask, don't tell, right? In the cannabis industry, it's not there yet. So that information and that data is very meaningful because for the first time, when you look at the food industry, they're still using Julius Petri and giving him a hug, right? They're still working with old world technologies. And what we've invented is quite a different toolkit. Now, quite a few states are failing samples. Why? Why is yeast and mold so high in most growers? Why? Because you're growing a product inside an enclosure and you got humidity, temperature, air, and water. It's perfect, right? It's just like the Amazon. You You're growing the Amazon in an enclosed structure, right? So the bottom line of all of this is that for the first time, I think in almost 4 or 5 decades, we've taken this tool and somebody's going to say, well, yeast and mold results are really high. It's over 50,000 CFUs. That means it's failed. Well, how do you know if it's good or bad? If he starts smoking weed with 72,000, something going to happen? We don't know, right? The bottom line is nobody's dug deep enough to understand what's in that yeast and mold. Is it brewer's yeast or is it aspergillus? If he consumes something at brewer's yeast, he's going to be fine, right? If he does it with aspergillus, he's going to be on his back. And so we've developed this technology called a quantitative microarray that gives you that resolution and that fidelity to understand what's in the product that you're consuming. Is it good stuff or is it bad stuff? An example, we saw an infused tea with 120,000 CFUs per gram for aerobic bacteria. Aerobic bacteria is like every single bacteria in your gut, right? And somebody says, this is failed. Well, the person that it was going to be administered to had cancer. She could no longer take it because the state failed. So when they finally dug into it, they said, and we were able to run the technology, they found it as bacillus. Bacillus is a probiotic. Bacillus is what we do every day. We eat yogurt, right? And that's the difference, is that you got to know what's in it, and when you draw the data out, it's going to be meaningful enough that it impacts the positive side of all of us from a quality and a health perspective. And that's sort of what our technology does. And it's all cloud-based so that when you start seeing this data, you're going to prevent some of the fires that you're seeing in these other industries that we're seeing. Of course, we can learn from them. Don't get me wrong. SOPs, GMPs, and so forth, great manufacturing practices. But we have the great opportunity to take this data and do good things with it.
And I'll just add one thing really quickly because I know our host probably wants to move on to another topic. But just to say something that might be a little controversial to some, cannabis is not medicine. What is medicine is cannabinoids. What is medicine are those individual bioactive molecules that are found within the plant. And the reality is we don't know what's good, bad, and ugly about any of those. So I think what we're most excited about is that we will be able to produce all of those at scale and actually test them to find out what is good, what is bad, what should we be consuming, what should we not be consuming. Because I'll be honest with you, nature is trying to kill you every day. When you read that something is good because it is natural, you do not have a 2-year-old. I'm up here addicted to cough drops because my little 2-year-old tried to kill me a week ago. Okay, so there are a lot of bad things that happen in nature, and I think if there are a lot of great things in this particular plant, and I think we really have to fundamentally understand what are those good things, what are those bad things, and how do we create products around that. So I will never make a product. I'm an ingredient provider, but everybody here, if there's anybody in the audience that's making products and wants to fiddle with these different cannabinoids to actually make things to help patients and help consumers, that's what we're trying to enable. We're trying to enable that next level of innovation that's going to come from much smarter people than us to make things that are actually consumable by patients. So I would say, I think from our perspective, the technology that's most interesting is being able to unlock even those minor cannabinoids for product development and innovation.
All right, I got to ask a question. I mean, you guys look at this panel. I've got scientists and basically brilliant guys. Like Trees is just trying to do simple things, right? We're just trying to make it so you can get product, you can get it through your system, it's compliant, you can sell it. Over here we have a physicist, we have some scientists. All right, Ben, what is your secret sauce? What do you do?
Yeah, people, and people. I actually left my last 3 jobs because the management teams did not take people seriously. If fundamentally you cannot be successful, I'm not a scientist. The only reason I know what I know that I can spew out to you all is that I've surrounded myself with brilliant young ladies and brilliant young guys that know this stuff beautifully. So I think the key to success in anything is that intellectual horsepower that you get from a team and surrounding yourself with the right folks to execute. So from my perspective, that has been it. I think in cannabis, there's something that's very, very interesting, and that's community. I think you're going to see a lot of I think we're naive to think that big companies aren't coming into this space. Pharma's been studying this for 40 years. The beer companies have been studying it for 15. All of these companies are going to come with products. So I think we as a community have to do the right thing from the beginning on all aspects of product development and consumerism. But I also think we have to hustle to build brand and build scale to make us attractive to those big guys when they ultimately come in. So I think we can't think in the now, we have to think in the 5 years from now when regulatory flips. So I would say it's people, period, both from a consumer and community perspective, but also who you surround yourself with.
Thanks. All right, you guys ready to find out the big question? The burning question? What does a theoretical physicist do here? How'd you end up here?
Thanks for taking that interest. The details of my life are inconsequential. What we care about is cannabis. Luge lessons in Switzerland. No, you guys know where I'm going here. It's an Austin Powers joke.
He's being super modest. He's not going to tell you about beats or anything like that. Come on, share some details.
So I studied string theory, which is a gorgeous piece of theory relating to how the universe works. It predicts naturally that gravity comes out of quantum mechanics, which is what Einstein tried to do the reverse of, and he got wrong. It also shows that details around what Richard Feynman did for us, which is the perturbative calculus of quantum field theory. It has led people down a rabbit hole for the last 65 years. I can't imagine how many PhDs have spent a dozen years or so doing some horrible Papia Fadaf ghost model and trying to figure out the nth order term to some expansion. It's all now being radically changed by string theory. What was beautiful is that as a theoretical physicist, I worked in mathematics that I never thought would have any application. And then I had a horrible divorce. And my life was blown up. And I needed to support everybody in my family. And a friend of mine at Facebook said, who had also done theoretical physics at Stanford, he said, you should do data science. And I was like, what is this data science? That's just a word. But it turned out, amazingly, that all the math that I had done in my previous life was perfect for deep learning, artificial intelligence, data science in general. So it's been an incredible thing because, I know he's the eye candy here, but it's really amazing to think that I would ever get a job doing mathematics. And I have. I mean, I thought I was going to be a professor all my life. So it's been a real fun ride, and the amount of things that I've learned from taking in huge data sets, exogenous data sets, you can tell so much about the world and the planet. And I think that the next generation of data scientists is going to be a journalist, and they're going to be able to sit there, download, scrape some resource, whatever it is, turn it into something that tells a story and has a cogent connection with what we care about, and teach us something that's very different than what we're currently exposed to in the mainstream media, which is, essentially just propaganda.
Thanks, Alex. All right. So I got to ask you guys.
Obama out.
Okay, hold on. What's the most important thing you guys have learned from data? Like, name something, one thing you've learned from data. Everybody's talking about data and data science and AI. Like, what's this actually mean to us?
I can add one thing. Last year, 3% of all the energy that was generated in the United States was consumed by the cannabis industry. $60 billion in energy spend.
And by the way, just to put that in perspective, the entire pharmaceutical industry used $1 billion.
So this market, there's three areas right now in when you're looking at data that are radically changing the infrastructure of the energy environment. Data centers, cryptocurrency, and cannabis growing facilities. They're the three most intense energy consumers that are in the market today. So at the rate that they're growing, at the expansion that we're expecting, they're going to have a serious implication, not just on energy in general, but also the energy infrastructure, because all of these growing facilities, they're not being built in the downtown areas that have redundant systems. They're all in these empty warehouses at the end of radial arms that don't even have enough power to power the warehouse, let alone 6 megawatts of lights. So how are we going to address that need? And that's kind of a scary data point that I see.
I think with data, you've got to be careful when you're looking at data, okay? It depends on how you analyze it and what you interpret in terms of information. Because you can jump to conclusions, and that's the risk, right? And so we're producing a crap load of data, all of us are. And you could take your company in a completely different direction, and it may not be the right direction. So that's one of the key things I've learned from, 45 labs worth of, processing 4,000 samples a month, right? You're taking a lot of data, but how do you make it meaningful? And you need people like him to help you figure it out, because, it's beyond just statistics. It's predictive analytics. It's, theoretical physics, and high-level computational mathematics. All of those things come into play to really make it meaningful from that perspective when you're talking about, a lot of data. So that's one of the things we've learned out of our sort of experience at Pathogen.
Yeah, and I think one of the interesting things about what we have cooking is we actually are the definition of kind of biotech. Biotech was originally meant to be this kind of weird marriage between biology and technology, but it never really came to fruition. So if you think about what we're doing, we're reprogramming nature. So we're writing not in ones and zeros, but in A's, C's, T's, and G's, DNA, the code of life. So when you think about how complex data science is just with ones and zeros, orders of magnitude more complex when you add just 2 more letters. So yeah, it's been very, very interesting. And we actually use a little bit of AI because what we have to do is if I change DNA code in a certain cell, I have to predict how that cell is going to react. And changing DNA code in one place changes something up here and something down here, and it all gets messed up. Nature has a weird way of kicking you in the ass that way. So we actually do use a lot of AI and kind of deep learning methodologies. I'll tell you the most difficult part for us, and I'd love to hear your thought on this, is actually structured data sets in a way where the data is actually in a form and a consistency that you can actually make intelligent decisions and algorithms based on it. I'd love to hear your thoughts on how you guys deal with that.
Am I understanding you correctly that you're asking about structured versus unstructured data? And
Yeah, so for instance, if I looked at cannabis genomes, there's a really cool company, Phylos. They have a booth over there. Go talk to them. They do a lot of really cool genetics. They do sequencing in one way. Monsanto has some interesting genomes in another. There's folks in Israel that have it in another form, and I'm sequencing things like yeast and microbes and heterotrophic algae. And all of that is done with different sample preparation, different machinery, different bioinformatics. So you have these data sets that are kind of not all the same. Do you run into that problem, or do you guys have pretty structured data that you can run those algorithms over? Because I think people think AI and it just works.
Yeah.
It doesn't just work, obviously.
Yeah, no, that's a great question. Yeah, no, it's always a mess, and the amount of structured data sets are so few and far between. So really, most of my work is figuring out how to get the most juice out of the data. If I have a client that has a ton of data, then it's great. I've had one client that I won't name, but they deliver all your mail. They thought that they had like the best data set in the world. They said, it's so much. We have a SQL database. We've got a Redshift data. It's incredible. What can you do with this data? And I downloaded a sample, and I put an information metric on it, and I said, this essentially explains 0 of the variance that you care about. And they were stunned and shocked. And then there's other clients that I have that have totally unstructured data, but that is renewable, highly valuable, can drive tons of different business units within the organization, et cetera, et cetera, et cetera. But I think if I've answered your question, essentially what's beautiful about AI is that even though the claim is you can throw a bunch of data at it, you just have to structure it in some minimal way. It has to be a matrix at the end of the day, and you do certain pre-processing and things like that. And like what you said, you have to be very careful about how you interpret it. I don't know how many data scientists that have taken a Coursera course and now love it that they're making good money have no idea about statistics. And they won't even understand, like, how do you even calculate a Bayesian posterior? And I know. God
bless you.
And so it's a crazy field. And I think the last thing I want to say here is that, I think we all have through society been taught that hackers are these people that break into data sets and do all this stuff. You know what? I'm probably the most dangerous hacker out there, not because I actually know how to infiltrate another, if there's security or encryption on it, I have no idea what to do, right? You need big data, you need tons of CPU to decode that thing, or you need to have a backdoor like the double elliptic, which the NSA has this.
Are we about to learn a secret?
Yeah. So my point here is that data scientist, machine learning person now is the new intelligence agency, because once you're in the system or once you have access to the database, now you can take all that and you can do things that no SQL query, no other type of column or row-like analysis could ever get back to you. And it's the same thing with clients that I have in the biotech industry. I've worked besides PhDs from Stanford, Harvard, wherever it is, in biotech, and they're still doing, looking at parametric plots in 2 dimensions. And so then I'll come there and I'll say, hey, you can actually analyze the whole thing in the 160 dimensions that you actually have in the data set. Or you can do polytope analysis that you do in DNA sequencing, which is probably some of the most deep, beautiful mathematics out there. And all of a sudden, they're amazed and surprised, like, hey, why didn't I know how to do this during my PhD? So it's an incredible field right now where, when you can bridge that gap and throw this data at all these different domains, you can gain a holistic or holographic perspective of everything.
All right, guys, we got 10 minutes left, so I want to save some time for questions, but thank you, guys. This was amazing. And Ben, thanks for wearing the shirt. You guys put your shirts on.
Yeah, super
let's
comfortable T-shirts from that guy, so make sure you buy them at the concession
So come by our
stand.
booth.
Yeah.
Yeah, come
His
by our
billboards
booth.
are
Come
ugly,
by.
but the T-shirts are fantastic.
And by the way, the founders are in the audience, so you guys can say hi to them. All right, questions? Anybody? All right, I'll come over. No, there's no mic out here.
That's all right. That guy needs a workout.
Hi. First off, thanks for coming and sharing the incredible work you guys are doing. It's really exciting. It's also really exciting because business is driving this rather than government or academia, right, on this front. And my question, it's going to be a little bit of a round way, but we can take examples from the industrialized food complex that we have, right, which is really taking the science, breaking it down. It's led to great global increase. People don't go to bed hungry, although actually that's true, that's more of a social problem. But we also are perhaps maybe not being honest about the fact that boiling things down to their basic compounds and then feeding people with it has actually left an entire population of people obese, sick, and stuck on a healthcare system that's actually not meant to help them. And I think what's really exciting is that you guys are actually building technology and sustainable revenue generation in order to identify this tech and actually do something really interesting with it. So I'm curious, saying first and foremost that you can't solve all problems and you can't be the moral gods of the space, but I'm curious, what is your moral compass? Like, what's your personal responsibility into this space? And then what are you doing to actually bake that into your business to make sure that as new information comes on board, that it's actually being integrated into what we know, do, and see in the cannabis space? I mean, there's more bacteria in my gut than there are stars in the constellation that we really know nothing about. So how are we taking these businesses and actually doing something impactful with that?
Yeah, awesome. Can I start with that? Because I know a lot about food. First, I would argue that the food pyramid made people fat and diabetic. So that was a government issue. And actually, there's a lot of cool stuff going on in food. You and I should talk about it later because GMO 2.0 is fabulous. I promise you, it is awesome. Read a book by my buddy Paul Shapiro called Clean Meat. He was an animal rights activist, and he's talking about this new age in food tech. But I'm deep into that industry, so you and I should talk.
Wasn't this the beginning of the Andromeda strain?
Yeah. So how are we thinking about the world? I think you're right. I can't solve all problems for all people. What we're trying to do is take this really complex, beautiful thing in nature and unpack it down to its variables so that they can indeed be studied. I think we're in a place right now with the cannabis plant where we know a lot less than we think we do. And that is not only the plant, but that's also the human body. So I think from our perspective, what we want to do is unlock all of these things so we actually can study them to know what's good, what's bad, how do we formulate for an individual, et cetera, et cetera, et cetera. So for us, it is all about education. I am also not trying to own the market. So my view is I want to help other entrepreneurs be able to do research, be able to do product development, and be able to open up their own shops. Quite honestly, I'm up here on stage and I had to do a pitch competition because Peter from LeafWire is my friend. I would rather nobody know who the hell we are. I would rather you all as entrepreneurs be the face of it, and I just help enable those businesses. So from my perspective, that's one on the product side. The other one is sustainability. So if you think about what our energy guy down there at the end was talking about, the reason I knew that $1 billion figure, by the way, is because that's a big reason why I got into this space. What would take you a 5 million square foot grow operation using 100% of your flower for extracts, I can do in less than 20,000 square feet. So just take that from a sustainability and a resource use perspective down. So from our perspective, it is all about enabling innovation, enabling science and understanding of these molecules as well as the human body as it relates to them in the endocannabinoid system, but also making sure we do it in a sustainable and a responsible way going forward from a production perspective. I hope that answered your question.
Hold on, let me ask one thing. Where's your moral compass?
Yeah. Yeah. I'm married to a Brooklyn, Queens, born and raised Puerto Rican gal, so my moral compass is wherever the hell she tells me it to be.
All right, guys.
I'd like to add to that. I mean,
Okay.
I think from an energy perspective, from the energy guy, we're all concerned about the environment. We're all concerned about climate change. We're all concerned about the elements that are affecting, the world we live in. And this business is a burgeoning business that is growing exponentially and consuming exponentially, more power. So from my perspective, my moral conscience is clear because I'm doing my damnedest to make sure that if it's going to happen anyway, I'm going to have them do it with the least impact as possible. So leveraging any renewable technologies, renewable energy, biomass, solar, wind, even arguably carbon fuels like natural gas versus coal or nuclear, so that at least if you're going to use a fossil fuel, it's 50% cleaner than everything else that's on the market, or it won't explode and kill you. So from an environmental perspective, I think we need to be responsible and we need to do things as efficiently as possible. And that's one of the things that we're trying to bring to the table is to make sure that as we grow these businesses, we do it with the most environmentally responsible way.
Can I comment? From Pathogen's perspective, we have a fiduciary duty right now because when you invent a technology that is so different, that is going to address a lot of the pain points that not just our industry is seeing, but these other industries are experiencing for decades, and both the testing standards as well as the toolkit that they're using is reactive. It's not proactive to tell you today. Let's remind yourself, 4 months ago you had romaine lettuce, right? By the time you find out that they find out the results, it's 7 to 10 days late, right? And you're already sick, you've gone to the doctor, and you're on your recovery cycle. So the beauty is that we have an opportunity here, and the moral compass that we have is that we have to implement this in key steps along the entire supply chain. How do you get clean cannabis? We have a product that can screen the entire grow to make sure that the air is not contaminated and winding up on the canopy. These are just building blocks that we're putting in place. Yes, it's capitalism, there's a key economic gain, but the bottom line is if we let it happen, then we will just be another food industry where you're going to see hundreds of outbreaks, people getting sick, public health issue, and the safety of our safety at risk. And so we've made a charter that this is what we're going to do in this sector, leverage our partners, leverage the major grows to do the right thing rather than spraying more chemicals on the plant and then it impacting us downstream. So that's what we're out to do.
Okay, I'm just going to take a second. Okay, let's commiserate because it's something that I think is really relevant. I think we could talk in depth about intellectual history. What are the guiding intellectual motives that guide us in our generation? And fundamentally, I think maybe many of us here would agree that most of them are all bullshit. And so it's a difficult thing to speak to in a world where most of everything that we've experienced is defined through some sort of negation, if you guys know what I mean. And so I definitely understand his perspective. Hey, we're going to distill this thing, we're going to provide a pure thing, we're going to enable industries to use that to make their own brands, et cetera, et cetera. But I would also encourage everybody here in the community to grow their own plant and to have that connection with the plant and to, if I dare use the word, to have this godlike experience where you're like, wow, this thing is breathing my breath, drinking my water, and at the end of the day, it's going to be interacting with my receptors in a really beautiful way. And I think that's what anybody who's ever had that experience has felt with their plants. It's a beautiful, beautiful experience. So in terms of moral compass, it's really important that we keep that in the forefront because it's so easy through the disguise of capitalism and everything that we do where money rules the world to forget these things.
Yeah. That was a blockbuster question. All right, guys, I didn't save enough time for any more questions after that. If you guys want to ask more, does anybody want to? Okay, come on up.
So this is a great question. This is really down to like build, buy, or steal, right? Can you have the capital expenditure to actually build your own system? What's that look like? Right now, there's a great rule of thumb that every few years, everything gets, a factor, an order of magnitude cheaper. So right now, if I was in the year 1999, for me to make a blog would have cost me hundreds of thousands of dollars. Now it costs me hardly anything. For me to now produce a system that I can spin up on AWS or whatever it is that can orchestrate a whole connection of dependencies, it doesn't necessarily cost that much. I mean, it still does, but it's on the order of a few $1,000s. So it really is a business decision. Right now, a lot of point-of-sale systems are really an incredible lobstering technique because they do provide you the convenience, just like Square does for payments and et cetera. But fundamentally, they're going to leverage that data as its own renewable resource for them. And at the end of the day, maybe you don't care. Or maybe there is a really good benefit to having your own data and sort of putting a perimeter around it.
Yeah, and I'll chime in on that one. So obviously, point-of-sale provider, we are working with data all the time, so that's a sweet spot for us. If I were to go out and build it by myself, you go out to Google Cloud, you go out to Amazon, there's a whole assembly of tools that you can use. So he's talking $1,000. They'll give you free credit. Like you'll literally be able to start this thing up and spin it up on your own. So you can get pretty deep into this process and you can get basic flows working where you've got data collection happening and you've got it then being piped into a warehouse and then you're extracting and you're looking at it with a reporting tool. So those tools exist and you don't need a lot of technical skill. You can get down to the point where you're talking about point click, look at something with a graphical representation and then, build reports. So you'd be surprised. And then, Alex didn't really touch on the data collection from the ad tech perspective, but, simple things like pixels, those are huge, right? There's all these little things you can do that are just dirt simple, dirt cheap, and you can get a huge amount of data. There's companies out there that are specializing in that, but you don't need that level of expertise to get to the point where you've got basics. So.
But I would say that in general, building anything nowadays, having an engineer and everything, it's going to be a headcount of about $150,000 per person. So if you need to have a 4-person team, you need to have budget for that, versus then integrating a POS system that also then, like MediaGel, we give you a dashboard and a view on what worked, what didn't work, what cohort worked, audiences, locations, etc. And so at that point, you're looking at that and saying, wow, if I had to build that, that would cost me $3 or $4 million, right? And I might not even get it right.
So let's go back to that moral compass since you said build, buy, or steal. All right, any other questions, guys? All right, I appreciate you guys staying late.
Thank you.